So we are looking at medical genetics, and today we'll look at DNA. Now, DNA, as you can see the structure here, is known as deoxyribonucleic acid. We'll explain why it is a deoxyribonucleic acid. But first of all, we should know that it is an organic molecule that carries genetic information in all cellular forms and viruses. Great. Now, DNA provides the genetic blueprint, for all proteins in the body. And don't forget that the human DNA is of a length of 2 meters, okay? Yet it is able to fit into the nucleus, which has a diameter of 5 microns. In other words, 5 micrometers. Okay, so how is it able to go into that? It has a compression unit, which is greater than 100,000 factorial, which is a greater form of compression. We will look at that when we are talking about chromosomes, how it is being able to wound into a protein spool into, and then fits into the DNA, fit into the nucleus. So that is that. Now, if you look at my diagram here, you'd find something that adenine is connected to thymine, and then guanine is connected to cytosine. This is known as the base pairing rule. The base pairing rule, which we would look at in a different video. But here we know that adenine, so just put that in mind, is coupling or pairing with thymine, as guanine is also coupling with cytosine. We have a sugar backbone, sugar phosphate backbone. We'll look at that later on. Let's continue. So the DNA molecule has 3 components. The first component is a deoxyribose, which is a pentose sugar, a 5-carbon sugar. Let us write that here. And then it also has a phosphate group. Okay, good. And then a nitrogenous base. But nitrogenous bases, but the nitrogenous bases comes in 2 different forms. Either it has a single ring or double rings. Now, if you have a single ring, then you are called pyrimidine. If you have double rings, then you are called purines. Now, this is how I remember it. The longer your name, the smaller your ring. So pyrimidines, very long name, has just 1 ring. The other one is purines, short name, 2 rings. So that is that. And then for pyrimidines, we have cytosine and then thymine. And then for purines, we have adenine and guanine. But adenine, as already said, will pair with thymine, and then cytosine would always pair with guanine. Okay? Yes. And then as I also wrote here, they are called nitrogenous bases because base, you know base? Yes. So named because they can combine with hydrogen ions to, combine with hydrogen ions in acidic solutions. And so if they can react with acids in a form of a neutralization reaction, then they are bases. And because they contain nitrogen in their rings, we usually refer them to as nitrogenous bases. So that is that. Now, there are some things that we have to look at. If you have a nitrogenous base plus a sugar, then it's called a nucleoside. That is diagram 1. If you have a nucleoside, which is the nitrogenous base plus the pentose sugar, and you add your phosphate group, then you have a nucleotide. So a nucleotide is the sum total of your pentose sugar, your nitrogenous base, and then your phosphate group. Now let's look at something here. You can see that instead of writing adenine, we have something here as adenosine. Now, there's a simple explanation I can give is that purines, once they form nucleotide, they take the name O-sign. So that's O-sign. Pyrimidines, once they form nucleotides or nucleoside, they pick the name idine. So let's say here, this is a nucleoside. We just have, what do we call it? we have adenine, and then we have a ribose sugar. Okay, a ribose sugar. Now this is even a wrong diagram. This is a ribose sugar. It's supposed to be a deoxyribose sugar. So let's just say I've cancelled the O. Now it's ribose. Sorry, it's deribose because it has lost O at carbon 3. Okay. Yes, it has lost the O at carbon 3. Good. Carbon 2, sorry. If you look here, it's carbon 2. Good. Carbon 2. 1, 2, 3, 4, and then this is carbon 5. So it has lost carbon at, it has lost oxygen at carbon 2. So anytime you are naming it, because this is an adenine, and then we already said that it will take the name O sign, this will become deoxyribose adenosine, okay, or simply say adenosine. And then here, because we have the phosphate group, and then we have, what do we call it? A phosphate group, and then we have the nucleoside. This, because this is the nitrogenous base adenine, if you are naming it, this will be, we name it this way, deoxy plus the nucleotide, okay? And then we said that the nucleotide is a purine, so it will take the O sign. So deoxyribose, okay? So we are picking out the ribose, and we are saying that, sorry, we are saying that deoxy adenosine, oh, sorry, I'm having adenosine 5, but monophosphate. You have to take time to understand the classification or the nomenclature. And then you look at where this is bonding to carbon 5. Can you see that? Carbon 5. And then because we want to show that the ribose sugar here, this sugar is, it has lost oxygen at carbon 2, we would probably do this 2-deoxyadenosine 5 monophosphate. So that is the simple description or nomenclature that we can give. Imagine this group was a cytosine, okay? Because cytosine is a pyrimidine, then it will take the name cytidine, okay? So let's say it will take the name cytidine. Good. Now, if we have cytosine here, the name will be 2-deoxycytidine 5 monophosphate. You are good. If we have the base, what do we call it? Let's look at some of the bases. We have the base guanine. You know, guanine is a purine, so it will take the name osine. So we would have 2-deoxyguanosine 5 monophosphate. But if it's what do we call it? A ribose sugar, which we will learn later on. Don't confuse yourself. They just pick the name adenosine. The nucleoside picks the name adenosine because the oxygen at carbon 2 is present. So we don't bring the name 2. We call them adenosine 5 monophosphates, cytidine 5 monophosphates, something like that. Simple naming, simple nomenclature. Now let's look at the bonds in the DNA helix. And there are lots of bonds, and there are lots of factors that stabilize the DNA helix. But here we are just looking at 4 of them, which is the hydrogen bond. Okay, we have hydrogen bonds which exist between the base and then the bases and then the complementary strand. DNA is said to have 2 strands. Let me just go up and then. So if this is the main strand, or this will be a complementary strand. If this is your strand, this will be your complementary. And so there is a bond that exists between them, which is their bases, and then the complementary strand, which is a hydrogen bond. And then we have a non-covalent bond that, or interaction that exists between the upper and then the lower surfaces of the bases. And so let's look here. Good. Between this and this, there is a non-covalent interaction. Okay, the lower surface and then the upper surface of 2 different nucleotides. Good. We also have charge-to-charge interactions, which is as a result of the negatively charged phosphate group, which can be reduced with magnesium ion. This can come in your exam, so just put it in mind. So we also have charge-to-charge interactions. And then we have hydrophilic sugar phosphate interactions. So be it the ribose or deoxyribose sugar, they may have hydrophilic interactions. And that is that for DNA, intro to DNA. We'll dive deeper in our later discussion. Thank you very much for watching our video to the end. God bless you. And don't forget to subscribe to our channel. Bye-bye.